Morning. My name is Narayan Prasad. I have experience of working in FITZI, Akash and Allen and other institutions. Right now, I am interested to join motion classes for which I am giving a demonstration on electric flux. So my topic of demonstration is electric flux. Now, the definition of electric flux. Let there be a uniform electric field of strength E, which is uniform. In this uniform field, let there be a disk or circular disk having area A. Then electric flux. Electric flux is defined as E, which is uniform over the area A, and electric flux is a scalar quantity, means it has only magnitude, it does not have any direction. Second, its unit, SI unit, is volt meter. Third, its dimension is m L cube T minus 3 A minus 1. This is the concept of electric flux. Now let's try to understand this concept by solving a question. Question number 1. In this scenario, it is given as the uniform electric field is E, which is uniform, and in this uniform electric field there is a area which is tilted at an angle of theta with the vertical. It is tilted at an angle of theta and the area of the disk is A. Now the flux that needs to be calculated, the options are, first option is electric field E into area A. Second option is electric field E A cos of theta. Third option is E A sine of theta, and fourth option is 0. Now, as we know, flux is electric field into area A. So, here electric field is given, area is given. So, my answer will be flux will be equal to electric field into area A. That is option 1. But will this answer be right? If this answer is right, then this scenario should be equal to this scenario, because this scenario gives me this definition E into A, and this scenario, if this scenario also gives me this definition, means both the scenarios should be same. But as we can see, both the scenarios are different. In this case, area is perpendicular to the uniform electric field, but in this case the area is not perpendicular to the uniform electric field. Then how come the answers be same? So this answer is wrong. This answer is wrong. This answer is wrong. Now, how to find out the right answer? For finding out the right answer, we need to change the scenario given in the question as in the definition. In the definition, it is clear that area is perpendicular to the uniform electric field. So we need to find out the uniform area perpendicular to the area. For finding out the uniform area perpendicular to the area, uniform field perpendicular area, we will resolve the electric field into two components, one perpendicular to the area and one parallel to the area. So what we will do? We will resolve the electric field into two components. This is the electric field given in the question and the angle is, this angle is theta. What I need to do? I need to resolve the electric field perpendicular to the area and one electric field parallel to the area. This is rectangular components. For doing rectangular components, we need to find the angle theta. If this angle is theta, this angle becomes pi by 2 minus theta because this is perpendicular, and since this is also perpendicular, this angle becomes theta. If this angle becomes theta, this perpendicular field becomes E cos theta and parallel field becomes E sin theta. So this scenario can be represented in two ways. One in which the field is perpendicular to the given area of magnitude E cos theta, and the other scenario in which area is like this and the field is parallel to the area which is of E sin theta. Now this scenario is the same as the scenario in the concept. So we can directly apply the formula. That is E magnitude of electric field uniform into area A. Here the magnitude of electric field uniform is E cos theta and the area is A. So the flux in this case will be uniform electric field of magnitude E cos theta into area A, which becomes equal to EA cos theta. And in this case, my flux will come out to be perpendicular electric field is 0 into area A. So the flux will come out to be 0. So the addition of both the cases will give me the net flux of this case, which will be equal to EA cos theta. So net flux will be EA cos theta and my answer will be second option. Now this solution seems to be right because it actually is according to the concept. This is the concept and this is the formula. I changed the question so that I can apply the concept nicely. So my answer will be EA cos theta. Now, is there some other approach also to solve this question? Yes, there is a second approach to solve this question. Now I am going to demonstrate the second way to solve this question. My objective is to find the electric field which is perpendicular to the given area. Means electric field strength should be uniform and perpendicular area. So what I can do? I can resolve area also in the perpendicular to the electric field and parallel to the electric field. So my second approach will be resolving the area into two components. One is parallel to the field and other is perpendicular to the field. My initial area is like this, which is A and the angle is theta. So I am resolving the area into two components. One is perpendicular, other is parallel. My parallel becomes A sin theta and perpendicular becomes A cos theta. And my field is given like this, which is uniform. So I can divide this scenario into two parts, in which one area is perpendicular to the electric field lines. Its magnitude is A cos theta and electric field lines is like this into E, which is uniform. And in this case, my electric field is like this, which is A sin theta, and electric field is like this, which is E. So this flux will come out to be electric field is perpendicular, parallel electric field is E, perpendicular electric field is 0 into A sine theta. So net flux will be 0, and in this case net flux will be electric field strength uniform, which is equal to E into A cos theta. So my answer will be EA cos theta. So what I analyzed? I analyzed that this formula can also be written as E perpendicular uniform into area A, and in other way also it can be written as E uniform into A perpendicular. So these two cases are the analytical expansion of the concept. Now this concept can be better represented in a vector way, that is dot product.